Good afternoon and welcome back to the enclosure. Want to thank you for your patience. This is a long overdue update. Life has been quite a bit of a roller coaster actually over the last month. Lots of stuff's gone on. I've had a large learning curve on the electrical. I am running a lot of 24 volt and some 12 volt DC lighting. Actually, I'm running a huge amount of 24 volt lighting, but most of it has its own driver, transformer step down driver. So for instance, this is one of my ceiling gimbal lights, LED lights, and it has its own driver that steps it from 110 volt AC down to, let me just check, indeed this is going to 27 volt DC, 20 to 27 volt DC. So I guess that is based on the dimming potential. Anyway, I have a lot of lights that don't have their built-in drivers, and basically I think I've talked in the past about how I'm doing these surrounds on the ceiling with sort of an LED light trough. Then I have LED lights that are underneath bathroom vanities. I have a whole bunch of floor spots that are going to go near the wall and sort of shine up against the wall as a architectural element. And then I've also got some on the stairway, on the treads to illuminate during the night. Anyway, I've got enough that it started to make sense to have a centralized power source instead of running a whole whack of tiny or small driver transformers. And by having a centralized set of larger transformers, hopefully my standby losses when everything's off will be much lower. That is something that I have in my notes. Obviously, it was told to me or I've read it somewhere, but I was not able to find where I found that information. And I've reached out to a couple of transformer companies and they never got back to me. But anyway, so because I'm running centralized DC, I had a big learning curve on what's required to send DC throughout the house. I'm used to just doing a small kitchen circuit, and basically the rule is if it's under 96 watts, it's not that important by electrical code. Once you get above that, you start getting into what are called class 2 and class 1 electrical circuits. And I'm going to be running some transformers that are 480 watts that are broken into a couple of circuits. That definitely got me into class 1 wiring. And I haven't done class 1 before. So that was the learning curve. And basically, it involved having to rethink how I did the electrical boxes. So for instance, here's a box that used to be a 2-gang plastic. But in order to do class 1 wiring, you have to separate the low voltage DC from the higher voltage AC. And that made things a lot more interesting because now, even though this is only going to have 4 conductors in it, I can't borrow the excess 2 conductors that are allowed to service this side of the bay. And so the reason this is loose is because step 1, I replaced the 2-gang plastic with this 2.5 inch deep 2-gang metal and put in this partition plate. But now my box fill on the 110 volt is too high for a single 2.5 inch box. So now I'm going to have to step it to a 3 inch deep box, and they only come in gangable boxes, which means it's a single gang that you then have to take a partition plate out and keep joining them up if you need multiple gang boxes. So that involved a lot of planning before I could figure out what my box fill was, and therefore my box requirements. I had to figure out how to actually wire up these fixtures in a DC fashion, including my computerization that I'm going to be doing. And so that is what this monstrosity over here is. And it's taken some time. I had to wait till I got the components from mail order. But basically what I've got here is I have both a 24 volt test circuit, which is doing 3 different circuits, and then I have a 110 volt circuit that is also computerized. So on the 24 volt circuit, I just have a cheap transformer that I use for testing that does my driving, and this is actually the computer. So this is what talks via Z-Wave technology. I decided to go with Z-Wave because it's a lot more approachable than, say, I think there's something called Phase 4 or Force 4, I think it's called. That gets into heavy bucks, professionals, highly technical professionals coming in and setting it up. And I wasn't interested in that. I like to play with stuff, and I like to play with parameters of the settings, figure things out. And so I decided on the Z-Wave technology, and then I decided to use HomeSeer as my Z-Wave controller. So I have a HomeSeer computer. It's at the suite across the street, and it talks to this building via Wi-Fi and a cable I have. And then it talks to all of the Z-Wave devices I already have in the house. So let me just put you down for a sec. I think I can do this without dropping you. And I can do this wonderful motion steady handheld. And I want to thank Andre from AF Productions. He's a friend of mine who does videography for various TV shows and whatnot, and he's donated one of his older handheld steady sticks, and it's made a huge difference to the quality of the videos. So I've got a power supply 110. I want to plug in my 24 volt driver, and what you're going to see is you're going to see a whole bunch of LEDs flash on when they first get power. And then we've got the 1 circuit, 2 circuit, and 3 circuits. So for the 1 circuit, I wanted to figure out how to do 3-way switching. So you'll see here, that one goes on, that turns it back on, or you can turn it off there and turn it back on here. There is a big learning curve on how to wire these up. They're not standard 110 volt wiring patterns. And what you need to realize, and it took me a while to figure this out, the switches are not carrying current. They're not carrying the 24 volt. They are just carrying a signal to this device to tell it to turn on, off, or up, down the 24 volt current to the fixture. And that took quite a while for me to get through my head, partly because I had a week where my back was really bad, and I had started to take one of my heavy duty pain medicines again. And I had forgotten the first time I took it, because I've been off of it for quite a while, that it caused some sleepless problems. And so I went almost a week without having more than 3 or 4 hours a night of sleep. And I was basically a zombie by that point. and not good for much. And so I got done, when I stopped taking those, it was a Friday that I didn't take them. And on Saturday, I got more done that day on planning than I had done the entire week. So anyway, so that's one circuit that got figured out. And like I said, it took a while to figure it out. I had to get the right switches. These are three-way DC switches, which are different than AC. They're actually certified for DC. I am trying to find, and I believe I just have found now after many, many, many hours of searching, these are toggles, which means there's an on and an off. But there's what's called momentary switches, where you actually have to press it down to hold it in that position, and press it down to hold it in that position, and when you release, it goes back to the center. That will actually allow for dimming up and down. Right now it's just going to the previously set dim level, which I can control with my phone. I can turn all of this off just by going to my phone and saying, I'm using the home stair configuration, and we're on the first floor, we're in the kitchen, and we have one on right now, which is that, gone. So, and I can dim and set accordingly. So if I turn this on, which is the other one, I have to go to that one now. I can set that down to, say, 32%. Now, when I turn this off and turn it back on, it only goes to that 32%. Oh, actually it didn't. Interesting, it went all the way up. It's not supposed to. Anyway, we'll come back to that in a future episode when we've actually got this in place. So with the three-way figured out, I then needed to figure out the single switches. As I mentioned, I think I mentioned, I'm going to have 3 or 4 of these in the house, each controlling 4 circuits. They can control a multicolor LED, red, green, blue, white, and make all kinds of fancy little colors out of it. Or they can control 4 individual circuits. And I'm going to be using the 4 individual circuits. So as a test, that's that one there. And then we've got that one there. So again, it took some time to figure out these are just activating the instructions in the module to dim up, dim down, turn on, turn off. So with the DC figured out, I then switched to AC. And again, I want to control all of the lighting circuits in the house, basically with the computer, with a smart phone, tablet, you name it, with devices that are in the in a light switch that are called scene controllers. So they have 5 different buttons, and each button can activate a different series of lights or an individual light. It can be made to make the lights flash if there's an emergency outside, that kind of thing. They're fully programmable. But the issue with even just standard non-computerized LED dimmers is that they're expensive. They're 40 to 50 bucks for a good quality LED dimmer. I think they're called pulsed wave dimmers. And I wanted to get away from having to have a specialized dimmer in every single light switch, because I've got a lot of 3 and even 1 4-way light circuits to allow for the convenience of being able to turn on the light at both ends of the hall, top, bottom of stairs, all that kind of stuff. So I've been searching on the web for some time for the right technology, the right Z-Wave technology to use. And one of the newer devices out there, it's called Zooz, Z-O-O-Z, and they have come up with a module, a smart module, that only has to be placed at the beginning of the circuit where that circuit receives its power from a panel or another part of the electrical system. So you only have to pay, and I think this is only 40 bucks, 45 bucks. You only have to pay for one for every single light circuit, which is going to save me buckets of money. And then all of the rest of the light switches are these cheap $3, $5, $7 light switches. So that ends up making the system much easier to use or to wire in. And again, there was some learning curves. The same concept here where the switches don't carry current, the same thing is happening on the AC side. So things really got crazy compared to a normal AC three-way or single wire up. The switches are only carrying a signal back to the controlling device. So this is just what I've got is I've got the LED that I previously showed you, the driver and the LED, plugged into a switched outlet, and basically, now I'm just using the dumb switch here, but if I go to the smart switch, I should be able to, oh, there we go. I just wasn't pressing it right. So I can dim that up, I can dim that down just within that smart module. Now again, if I can find a AC momentary switch, and I believe they're a lot more common than DC, then I'll be able to dim from this side of the circuit, not just the smart side. So again, are we dimming? Yeah, we're dimming. So and it's flashing because I'm actually going too low. There is a minimum load, and the single small LED isn't doing it. But there's parameters I can set here that set how fast it dims up and it dims down when I press and hold the button. This is actually a momentary switch. I don't know if you can hear it. It's clicking when I press, and then when I release, it's going back to the center point. And that's basically what I'm wanting for all my switches. Okay, so with the AC and DC figured out, I then had to figure out where all the transformers were going to go. And then I had to figure out the fusing. So I'm going to unplug this because, and I don't leave this plugged in. This is an unfused system right now. And what that means is that there's no secondary protection in case the transformer goes wild and starts pumping out ridiculous amounts of DC current. You must have what's called an inline fuse between the transformer and the circuits. And this can be one of those cheap glass fuses that are on older cars or in your microwave or that kind, your cigarette lighter connector charger for whatever. Or I am going with a little bit better quality and usability, but not terribly expensive. They're $5 to $10 a piece. A circuit breaker that you just press in. If it pops, you just press it back in to reset it. And so, thanks to Jonathan, my nephew, who has a lot more electronics knowledge and training than I do, he told me some things on email, and I was able to order my circuit breakers this morning. So what you want on a DC fuse and or circuit breaker is you want a voltage at or above the voltage that you're running in your system, and an amperage at or below the amperage that you're running in your system. And I was looking for a 24 volt fuse, and everything was either 30 or 50 volts, and it was like, well, that's not going to work. And actually, yes, it does. As long as it's the right amperage, that works. Now, don't ask me, I'm not an electrician and I'm not an electronics expert. I don't know the theory or how that all works, but as long as if you have, and let me get my calculator out here. Let's say you have 150 watts of lighting on a 24 volt circuit. You divide the 150 by the 24 and it gives you 6.25 amps. That's the amount of current that you're going to be sending through the system. So in this case I needed basically a 7 amp fuse or circuit breaker. So that's what I've done. I've ordered those and they should be coming shortly. They'll go into junction boxes between the transformer and the circuits being fed by the transformer. The transformer itself must also have fusing in it. And fortunately, the better call, this is just a cheap piece of junk that I just use it for testing. But the more expensive transformers, the better quality ones made in North America, they have fusing built into them, both on the AC side and the DC side, where it will cut out if it goes over parameters on either side of the equation. And so I've got one here, I'll show you. I think you can even see the fuse. This is a magnitude magnetic driver, LED driver. And hopefully, can we see this okay? It's a little bit dark. I'm going to try to put some light on it with my cell phone here. Bear with me. Okay, that's better. And this was interesting because this is a certified, it's CETL and USETL transformer. And I thought you had to have a partition plate between the AC and the DC side of the transformer, but you can use another rule which just says there's a certain amount of room between the two sides. So the DC side is the red and the purple, and the AC side, there's the ground, your hot and your neutral. They go out one side, the DC goes out the other side. I don't know if you can see it, that little black thing is the fuse for the two systems, like the AC and the DC. So this is a sorry, I'm trying to get the shadow off. This is a 150 watt transformer, 24 volt, and this will be what I use in the kitchen. So this will feed all of the kitchen drawer lights, the automatic drawer lights. I'm getting those from IKEA, and instead of using the IKEA drivers, I'm going to use my own centralized driver. The soffit or the valance lights underneath the cabinets, and then also it's going to run the perimeter light in the ceiling. So what I wanted to do is I wanted to figure out a good place to put this. And so I'm going to have my kitchen sink cabinet here and a corner cabinet there, and I think I have a 15-inch wide drawer unit here. Over here I had a gap, well, you can actually see it if you look closely on the ground, the lines here to here, where it would have just been basically a cover plate across to join up with the cabinets that are coming down the island on this side. And I decided that would make a great little spot to put the kitchen power system. And I'll have basically, instead of this being a cover plate, I'll have it as a door. And so it's completely accessible and it's not hidden and all that kind of stuff. And so I've got a 110 volt supply. It's going to go to the DC AC transformer driver. And this is even a dimmable driver, so if I wanted just to have this for an entire lighting circuit, if I had a need for 150 watts of LED driving, I could just have a centralized dimmer that dimmed the driver instead of dimming the individual DC circuits that are coming off of it. And so off of that, I will bring a junction box. The junction box will have the circuit breaker, the DC circuit breaker, resettable circuit breaker in it. And then from there, I'll feed the various circuits that I've got. So that I think was a good way of dealing with the location. The other drivers that I have and transformer step-down drivers are going to be in the guest entrance closet, and basically they're going to be behind that beam. So that will this entire closet is basically, there's going to be a closet portion of it below, but above is going to be basically a utilities closet. I'm going to have my heating system manifolds in there, and then on the back side of this beam, and I've already started running some of the required junction boxes, I will have the AC supply to the DC transformers, and then the junction boxes that the circuit breakers are going to go into, and then the junction boxes that feed all the individual circuits. And this is where I've got all of my outside LED soffit lighting coming to. It's where I've got my Christmas light supply circuits coming to. So basically it's going to be a mass load of circuits that are controlled in that closet. So with all that done, then I was finally able to figure out the routing of all of the cables throughout the house, and I've got them all now drawn in AutoCAD because there's the saying, fool me once, shame on you, fool me twice, shame on me. Well, I'm on the fool me 3 times. I've replaced some of these boxes 3 times because I just haven't been thinking through the process, and I don't have time to be redoing work that I've already done. One of the key ones is here. I had at one point this was a 4-gang metal box. Realized that I had forgotten a circuit, so okay, fine. These are actually the gangable boxes that I was talking about earlier, so they actually screw one to the other. But getting back, I thought, okay, fine, I'm going to put in the 5-gangable boxes, because they don't make a 5-gang metal box that's all one piece. And then I got through all of this and realized that I have far too much fill in these boxes. So this is actually going to have to come out and become a 3-inch deep box, gangable box, so that I can put in so I can put in the required number of cables, conductors. So fill refers to the number of conductors allowed in a box. And it's a fairly complicated set of rules. It's not just what comes into the holes of the box. It's also what goes on inside the box. And I'm just listening to my inspector who says, use all 2.5 inch, and if it's too crowded, put in larger. And that he wasn't even necessarily willing to go through what the rules were. So this is now going to be swapped out for 3-inch deep gangable boxes, 5 wide. This is the only location I have 5, by the way, and I'm doing so. I've got a Z-Wave scene controller, which allows me to do automation of 5 different things, and you can have scenes. I think there's actually 2 settings. You can have scenes and or combinations of things. So it's pretty cool. So for instance, I can come in here, let's say I come in this door and it's after hours and the house is dark. I can press the button that says lights on, and it turns all the common lights, so kitchen, hallways, bedroom, that kind of thing on, so that I can navigate through the place. Or let's say I'm leaving through this door, and I've got one of these at the front entrance, I've got one of these at the family entrance. I can say all lights off in the house, in case I've forgotten to shut off a light. Then I've also got the sidewalk, so I've got the lights that I've embedded in the siding that shine down on the sidewalk. I've got a spotlight up at the southwest side of the upper floor shining down on the backyard. I've got controls for the outdoor conversation pit / barbecue. This will turn the power on and off to the red circuit. And then I've got the door light itself. So the 5 was required. So what else? And of course, I talked earlier about the fact that if this did have AC/DC, then I'd also have to have the separation plates, the low voltage separation plates in between the bays, between the AC and the DC. So what else can we talk about? I think that's about it for boxes. I'm going to show you a series of short videos that I did on various tips and techniques that I've picked up either from a person who's now, actually he's now retired, but he was an electrical inspector for Burnaby. And prior to that, when I first started to know him, he was the electrician for the condominium unit I used to live at. And I used to hang out and do a lot of the maintenance work on the building. And so we had an opportunity to work together quite a few times. And I was able to learn quite a bit from him.